All right, so we are in Chapter 1, Lesson 5 for Math 8. This is all about zero and negative exponents. So first, let's go ahead and read kind of the main concept questions alongside here. It says, how are negative exponents and positive exponents related? So we need to kind of think about that. And then students use the laws of exponents to write and simplify expressions involving negative exponents. So that's what we're going to do. So if we come over here and we look at the notes area, we have zero and negative exponents. This was taken from the textbook. So any non-zero number to the zero power is 1. Any non-zero number to the negative n power, so any number is what n means, is the multiplicative inverse of its nth power. So what does that mean? So let's go ahead and look at the examples here. And I'm going to zoom in just a little bit so it's a little easier to look at. Oh, why isn't it not zooming in? I have to keep holding the space bar. That's why. Okay, interesting. Funny settings. My pen tool changed some of its settings here. All right, so we have 5 to the 0 power, and that equals 1. And then we can look at over here, and we have x to the 0 power, and that equals 1. So they're different numbers, but whenever we raise something to the 0 power, it equals 1. So it doesn't matter if I have 1 million. If I put a 0 on there, it equals 1. Does not matter what the number is. Okay, so as soon as I raise that to the 0 power, it becomes 1. Now if I have a negative exponent, and we're going to go through and kind of explain what this math definition means here, because I think it's a little bit complicated sounding, but it's really not a complicated concept. So a negative exponent doesn't actually tell us that it's a negative number. What it tells us is it's in the wrong spot. That's how I like to refer to it. So if we always remember that numbers, and in this case we have 7 to the negative 3, all numbers have a 1 under them. Technically, they're all fractions with a 1 as a denominator, okay? We just don't write them like this because it would definitely be a little busy looking and start to get a little complicated. So if it's a 1, we tend to just drop it away and it's not there. But it's always there. It's just invisible. So the negative exponent, what it tells me is it shouldn't be in the numerator. It should be in the denominator. It's simply telling me to take this number and move it from the top of the fraction and move it to the bottom of the fraction. So just like they're doing here, and they're showing you 1/7, 1/7, 1/7, I like this view because it's actually showing you that 7 to the 3rd power went to the bottom. And now it's a positive 3. So once I move it to the correct place, it becomes positive. And if I didn't really swap the 1 and the 7, but because I'm moving it down, there's not nothing left over there. There's a 1 left over. So it kind of looks like I swapped them in this case, but that's not truly what's happening. What's happening is I'm moving it down, and it would be 1 times 7 to the 3rd power, but anything times 1 is just itself, so we don't write the 1 anymore. And then on the top, it was already 1 times 7 to the 3rd power. Because again, we don't write the 1 there, but it's always there, just like the 1 underneath. It's just convenient to remember that it's there because that's what got left behind. So again, it just means it's in the wrong place. If it's on the top of the fraction, it should move to the bottom. If it's on the bottom of the fraction, it should move to the top. Okay? So that's the kind of my way that I like to explain negative exponents. So if we look at this, we have 6 to the negative 3rd. Again, doesn't mean negative. It means it's in the wrong spot. So it means I need to take this 6 to the 3rd and move it to the bottom, just like they did here. 1 is left over. 6 to the 3rd. It's now positive 3 because it's in the correct place. 5 to the negative 3rd. So just because it's a variable doesn't mean anything. It's still a number. It's just a placeholder for a number. So again, we have over 1. It's telling me it shouldn't be in the numerator. It should be in the denominator. So I just move it down. So now 1 gets left behind, and I have 5 to the positive 5th because I have it in the correct place. All right, let's practice a couple more of these down here. So we have 7 to the negative 2, or negative squared. I guess it's kind of a funny way to say it, but again, here's our fraction. It means it's in the wrong place, so I'm going to move it down. So it's going to be 1. That's what gets left behind. And then 7 squared. Now it's positive. Could I go further and actually simplify this? Sure, I could do 7 times 7 is 49, so it'd be 1 over 49. I think for right now, all they want us to do is go to this point. So we have positive exponents. So we don't have negative exponents anymore. All right, so this guy, same thing, has a 1 on the bottom. And I want to take this negative exponent and I want to make it positive. So I'm going to move it to the bottom. 1 gets left behind on the top, and now it's positive 4. So b to the 4th power. This one we couldn't simplify any farther because we don't know what b is. So this would definitely be the end answer unless they told us what b is going to be. All right, let's see. I'm going to scooch down. Do 2 more of these. So remember, anything to the 0 power, it does not matter what it is. As soon as you see the 0, it equals 1. And I've actually seen, some kind of more complicated looking ones. I'm doing z to the 10th power like this, and then they put a 0 on the outside. Well, that means everything is raised to the 0 power. The answer is 1. So 0, doesn't matter how many things are raised to 0, it means 1. But if only one of these had a 0 power on them, then we'd only apply it to the 1, okay? I'm definitely getting a little more complicated here by showing you that one. But I've seen that where it's a very kind of long, complicated looking problem, and they put a 0 on the outside of the parentheses, which really just brings us back to this very basic rule. If it's to the 0 power, it's 1. All right, so this is very similar to b here. We have our kind of fraction set up. It's in the wrong place, so I'm going to move it down. Once I've moved to the right place, it is now positive. All right, let's look at page number 2 here. Oh, I forgot my settings changed. Oh, this might be section... Oh, no, it's still section 5. I thought we were moving to section 6 there. Okay, so it says complete the table. So we're going to look at this table here and explain why a number raised to a negative power does not result in a negative number. So remember, we were just talking about that. The negative exponent does not mean it's a negative number. What it means is it's a fraction, and it's in the wrong place. So it just literally means we need to move it down. So we still apply it the same way we would a positive. That's how they're related, the negative and positive exponents. 2 to the negative 3 is still 2 times 2 times 2. It just means that it's on the bottom of the fraction instead of the top. So if 2 to the 3rd power is 8, 2 to the negative 3rd power is 1 over 8. 2 squared, so they're showing us 2 to the negative 2 is 1 over 4. Well, 2 squared would be the 4. We just don't have to move it down. It's in the correct place. It's positive. 2 to the negative 1, well, anything to the 1st power is itself. Just make sure to move it to the bottom of the fraction. And then this guy would be 2 to the 1st power is 2. Anything to the 0 power is 1. So remember, negative exponents do not mean negative numbers. It actually means it's a fraction. It's in the wrong place. Move it to the bottom of the fraction. If it's already in the bottom of the fraction, we may start to deal with that at some point. Then we move it to the top of the fraction. All right, we are going to look at this example here. Oh, dang it, I keep forgetting my tools changed. So we have 1 human hair is about 0.001 inch in diameter. Write the decimal as a power of 10. So we're starting to look at scientific notation a little bit here. Not fully, but they're introducing it a little bit. So if we look at this and we wanted to move this over, we go 1, 2, 3. And that would make it 1, which is why we have 1,000 on the bottom. This is how we write a decimal into a fraction. We see how many spaces I need to move it, and we put a 1 with that many zeros. So I had to move it 3 times, so I have 1 with 3 zeros. And then what they want us to do is start reducing this. So, and I know this is a little blurry in here. Sorry, it's again the way I take the pictures. They, for some reason, come out blurry when I do it this way. So I may have to find another way to take the pictures so they don't look like this. But in this case, we have 1 on the top, and they changed it. Instead of 1,000, they have 10 to the 3rd power. Because 10 times 10 times 10 gets us 1,000. So we're writing it as a power of 10. So they told us what to write it as a power of. They wanted us to bring it down to 10, and then how many 10s do I need to get to 1,000? And then we can also write it as a negative exponent here by going backwards. If I didn't want 1 over 10 to the third power, I just wanted to kind of simplify it, I guess, a little bit there. I could move this to the top. It's in the wrong place now. Remember, it's not supposed to be in the numerator. It's supposed to be in the denominator. This is a positive 3. So when I move it to the top, there is technically 1 left on the bottom, but now we can drop it off. We don't need to write it anymore. And that exponent becomes negative 3. Again, indicating it's in the wrong place, or, that simply it was a fraction, or it will be a decimal. Because look, we started with a decimal too. So that's another way to think of negative and positive exponents. Positive exponents are kind of large numbers, or numbers more than 0, and negative exponents are going to be numbers that are small or less than 0. Sorry, not less than 0, smaller than 1. I'm losing my mind when I'm saying that. So larger than 1, smaller than 1. That's the difference between the two. All right, a water molecule is about 0.000000001 meters long. Sorry, I did not say the number quite correctly there because I just didn't count it and see how many spaces it was over. Write the decimal as a power of 10. So how many times do we have to move this over? We have to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 times. So I have 1 over 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Doop, doop, doop. So that's a very large number there. So what we want to figure out is how many 10s are in this very large number. And you can do this a couple different ways. I'm going to open my calculator real quick because I think that's probably the easiest way. So I had 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So if I divide by 10, that's 1 10. Now I can hit equals again. That's 2 10s. I can hit equals again. That's 3. Equals again. That's 4. You just need to keep track of how many times you hit equals. Equals again. That's 5. Equals again. That's 6, 7, 8, 9. So I need 9 of them. So that's kind of one way you can go through and get this done. Did I not put enough zeros in? 1, 2, 3, 4, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I did. I want to make sure that I got that number right. Oh, my calculator in here won't let me go. There we go. Now it'll let me go. That's 9. That's 10. Okay, so I think what I did do, I forgot one of the zeros when I typed it in that first time because the commas weren't there, dang it. So I did skip one. So one thing I wanted to relate this to, because that's what I was a little worried about when I saw that, is if you notice, this 3 indicates that there were 3 zeros. So then if we look at this one, I should have 10 zeros, which means that I'll have 1 to the 10th power, and I should have it to the 10th power. Because 10 to the 10th power would get me this very large number here. So we just want to make sure. Basically, we're counting the zeros. That's another way we could do it if we didn't want to do the calculator there. That was just supposed to be a cute little exercise in doing it, but I had typed in not enough zeros there. So if I scooch down, I think that might be the only one there. Oh, yep, that was the only one. All right, so we are all done with section 5, and I will see you in section 6.